The faces of a pentagonal prisms are connected to form a three-dimensional figure as shown below. Here it is. Here we see. Find the number of vertices of the figure that is created by connecting 51 pentagonal prisms. Well, let's have one here and take a look at the number of vertices. What is a vertex anyway? So shall we take a look here? Here's a pentagonal prism in action. Obviously, when you look from the top, this is a pentagon, and this is a prism shape. You may not feel that way, but if I show you this way, this is a prism, isn't it? This is a triangular prism because it's a triangle and it's a prism. So I can increase the number of sides. When I have 4 sides, well, this is a rectangular prism, but also known as cube in certain cases, if the length happens to be the same. And then next comes the pentagonal prism that I was talking about, and after comes hexagonal prism, and heptagon, octagon, and so on. You can see it's an octagon, right? It's a prism. So I think you know what it is. But the issue is how many vertices we have. Vertices are these sharp corners that we are talking about. The easiest way to think about it is that to realize that on top and on the bottom, you got same number of them. So this is a pentagon. So on top, I got 5 of them. And if I look at the other side, there will be 5. So don't bother going down there. Just look at the top and count and multiply by 2. Then you'll be okay. So there are 5 vertices. Times 2 is 10 vertices. That's the situation with this pentagonal prism we have here. So what are we talking about? We have how many? 10 vertices if I have just one of them, right? Okay. Then what if I bring in another? Like that. You would think it would bring another 10. Yes, it does. But to simplify our thinking here, let's not look at the bottom here. Let's look at the top here. I used to have 5, right? And then I brought another 5 here. Do I have 10 vertices on top here? No, I got 1, 2, 3, 4, 5, 6, 7, 8. I don't have 10. I got only 8. Why? Because these two got they overlapped. So yes, you brought in 10 more. 5 more, but you lost 2 from the original one because they overlapped. And if I go on with this, then you will see it happens again. So here, when I bring in another one here, I bring in only 3 more additional one. And then if I bring another one, then to the existing one, I only add 3 more. Well, I'm counting only the top, so if you count the bottom also, then I bring 6 more, right? 3 on top, 3 on bottom. 3 on top, 3 on bottom, and so on. So do I have to go on, right? You can see what's happening here. So this each time this is added here, you are adding 6 more vertices. So in the beginning, we had 10, right? 10 on top, 5 on top, 5 on bottom. And each time you're bringing here, we have 3 on top, 3 on bottom, 6 more. And however many more you bring in, that's what you get. So here we are dealing with 51 pentagonal prisms. So first one had 10. And each 50 that you're adding, it will bring in 6 more. So this is a 10 plus 300. So there are 310 vertices in the end.